Okay, this is Giancoli, chapter 14, number 5, example 5. We're probably going to do this in two parts because there's going to be some bookkeeping that we need to do at the end, but let's just see if we can set it up so we can understand what's going on here. So what it is that we've got a engineer with an alloy that he wants to determine the specific heat. So what he does is he takes this at a specific initial temperature to 540 degrees Celsius, and he puts it into a water bath. We've got this water that's initially at 10 degrees. That's my T initial for the water. And also we've got the aluminum container that this is all in. It's also got an initial temperature of 10 degrees C. And what happens is heat will go into the water and into the aluminum such that later on the alloy and the water and the aluminum will all have the same final temperature. Whoop, that's supposed to be A. My alloy, my water, and my aluminum all have to have the same final temperature. Now, so there's a little bit of bookkeeping with this one, so that's why we're just going to set it up. Now, what we need to know is aluminum has a specific heat of 900 joules per Kelvin degrees C. My water is my usual 4186 joules per kilogram degrees C. And so what we want to do is first, I'm just going to set up the equation. So what do we know? The temperature, the heat lost by the alloy, which we're trying to figure out its specific heat. Let's write that down. We know that the heat lost by the alloy has to be the mass of the alloy, which we know, that's going to be in here, times the specific heat of the alloy, that's what we're trying to find, times 540 degrees, that's my initial, minus my temperature final. That's how much heat it leaves here. And so the little bit goes here, a little bit goes there. How about for the water? The water, what's the equation for that? Well, that's going to be the heat that goes into the water, so we reverse the final from this initial here, is the mass of the water times the specific heat of the water times its temperature final minus its initial temperature, which that's the 10 degrees Celsius. Okay, and how about the aluminum cup? The aluminum is going to be QAL equals the mass of the aluminum times its specific heat, which we just look up, times its temperature final minus 10 degrees, that's its initial temperature, Celsius. So what we say is this, the heat that leaves the alloy, which we're trying to find out CA, must be the same as what goes into here and what goes into here. So what we're going to do here, we've got two equations, two unknowns, but what we want to do is, and they tell us the final temperature is 30.5 degrees. That's going to make it a lot easier. So what we're going to do is substitute these in here, and then we're going to do the equate. And that's what I'll do on the next slide.